Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about coordinate geometry. Now the question that I've chosen to go through here is 2018 paper 2 question 5. The first part of this question is relatively straightforward. They've told you that M is the line 2x plus 3y plus 1 equals 0. And they've told you that A is the coordinate minus 2, 1. And you're asked to verify that the coordinate A is on the line M. So in order to verify a point is on a line, you just sub it in and you should end up with 0. So instead of your x, you can sub in minus 2. Instead of your y, you can sub in 1. So as you can see, I've just rewritten the line M, except I've subbed in minus 2 and 1, and it works out and you get 0 equals 0. Now obviously, almost everyone doing Leaving Cert higher level maths will get that right. That's a very straightforward question, so just verify it, you conclude. So you put a tick beside it and you say, therefore the point is on the line. Just you never know, they could mark that really harshly. Usually you'll get the full marks for just subbing it in, but just cover yourself. You get into the habit of making conclusions. In the second part of this question, we have the following diagram. Okay, so I know this is the line M, and the equation is 2x plus 3y plus 1 equals 0. This is the line N, and the equation is 2x plus 3y minus 51 equals 0. Those two lines are parallel, we were told at the start. Their A and their B are the same, so they're parallel. I know the coordinates of A is minus 2, 1. And they've drawn this broken line, which is the perpendicular distance from the line M to the line N. Okay? And they've also marked in this symbol, so that's my perpendicular symbol. I know that the line AB is perpendicular to the line N and to the line M. The question is to find the coordinates of B, which is the point that is closest to A on the line N. Okay? So this one, all of the maths here is relatively straightforward. It's all from the junior cert, but it's just about figuring out what you should do. The easiest way to do this question is, first of all, to find the equation of the line AB. Find the equation of the line AB, and then you can just do a simultaneous equation to get the point of intersection of the line AB and the line N. Okay, so what I've done on the board here is I found the equation of the line AB. You should recognize that in order to find the equation of a line, you should use y minus y1 equals m times x minus x1. So you need one point and you need the slope. The point in this case is the coordinates of A, which we've used at the start of the question. I know a point on the line AB is minus 2, 1. But the problem before you start this is you need to figure out the slope. Clearly, by virtue of the fact that AB is perpendicular to M, I can find the slope. So the first thing I did was I found the slope of the line M. Okay? Now obviously you can find the slope of the line M or the slope of the line N because they're parallel, so it's the same. There's loads of different ways of getting your slope. You could use minus A over B and you just get straight to minus 2/3. However, the way that I'm using this is I'm rewriting the equation of my line in the form y equals mx plus c. So I've isolated the y. And when I get y on its own, I know that the number in front of x is my slope. Whatever is in front of my x, when it's in this format, is my slope. So I know the slope of the line M is minus 2 over 3. If the slope of M is minus 2/3 and the slope of N is minus 2/3, the perpendicular slope, I just get the reciprocal, I flip the fraction and I change the sign. The perpendicular slope is plus 3 over 2. So I know now that the slope of M, the slope of the line AB must be 3 over 2. So I know a point on the line is minus 2, 1, and the slope is 3 over 2. So I subbed into the formula for y minus y1 equals m times x minus x1, and I ended up with the equation of my line is 0 equals 3x minus 2y plus 8. So now that I know the equation of the line AB, and I know the equation of the line N, I can do a simultaneous equation to get the point of intersection, which is B. And that'll be the final part of my question. So try it yourself before you watch the end of this video. So we have a relatively straightforward simultaneous equation here. N is 2x plus 3y minus 51. AB is 3x minus 2y plus 8. Clearly remember on your diagram, the point of intersection is clearly the coordinate AB, which is what I'm looking for. So if I do a simultaneous equation, my answers will be the coordinates of B. I simplified this out and I ended up with x is equal to 6 and I ended up with y is equal to 13. But you make sure you write it as a coordinate. So you have to write, your answer needs to be B is the coordinate 6, 13. A lot of students forget to actually write it as a coordinate. Okay, the final part of this question now, they introduce two circles. and the circles lie along the line AB. Okay, the diagram here gets very messy, and for me the only thing that's actually relevant is the line AB. That's the only diagram you need to simplify this. The question is to find the equation of S, the smaller circle. To get the equation of a line, you need the center and you need the radius. So you should straight away realize the two pieces of information you need are the center of the circle S and the radius of the circle S. And the only information you have really at the moment is that A is -2, 1 and B is 6, 13. Now you'll notice that I've marked in another point here, X. I want you to view X as the point of intersection of the two circles. The point where the two circles touch rather than intersect. Okay? So I want you to just view that. Now think of the proportions here. They told me that the radius of S is 1/3 the radius of T. In other words, that this is 1/4 of the total distance and that this is 3/4 of the total distance. Now, so the first thing I've tried to do is you should find the distance from A to B. So the easiest way to do that is just use your distance formula from your log tables. I've worked it out here, and I worked out the distance from A to B is 4√13. If the distance from A to B is 4√13, well, I know that 3/4 of that will be the diameter of the large circle. The diameter of the large circle will be 3√13, which means the diameter of the small circle, S, which is the one I'm interested in, will be 1√13. So the distance from A to the point that I've made up there, which is X, the diameter of the small circle is √13. Obviously, if I'm trying to find the equation of a circle, I've no interest in the diameter, I want the radius. The radius, if you have the diameter, you just divide it by 2. So the radius of the circle S is just √13 divided by 2. So it's relatively straightforward to work out your radius. It's a little bit trickier to work out the center. So to work out the center, I think the easiest way to do it, or the most efficient way, is to use this formula, your ratio formula. You need to figure out what proportion of the way from A to B will the center of the circle be. If you think about this first, you could use the ratio formula to find X, because X is 1/4 of the way from A to B. So if I divided my line in a ratio of 1:3, in other words, I'd find 1/4 of the way across, I'd find the coordinates of X. However, we can bypass that step and we can go straight to the center. If the distance from A to X is 1/4 of the total distance, then obviously if I only go half that distance, then the distance from A to the center of my circle will be 1/8 of the total distance. So actually you're better off here to divide your line in a ratio of 1:7, because 1/8 of the way from A to B is the center of the circle S. So that's what we're going to use in this case. So I want you to try this yourselves now. You could, in this case, if you're dividing your line in a ratio of 1:7, you could say that, right, my A is 1 and my B is 7. So that's how that's going to be your ratios. And if you've decided that 1 is your A, then this has to be your x1 and y1. And this has to be your x2 and y2. Remember, this is the only formula in the log tables where it does matter which one is x1, y1 and which one is x2, y2. So once you've assigned your ratios, if I've assigned 1 to A and 7 to B, I have to assign x1, y1 to the one that's beside my A, and x2, y2 to the one that's beside my B. So sub in there, and I want you to see if you can find the center of your circle before you watch the rest of this. Okay, so once we've already worked out our radius is √13/2, and we've identified that 1/8 of the way from A to B will be the center of the circle S, which I've labeled as C. So that means I'm dividing my line in a ratio of 1:7. In other words, my first ratio is 1, my second one, my B is 7. And my x1, y1 is -2 and 1, my x2, y2 is 6 and 13. My formula in the log tables, always write out your formula and the information you have. Once you've done that, it's foolproof. You just sub in your values and you work out that the center of the circle S is -1, 2.5. So now you know the center of your circle and you also know the radius. If you know the radius is √13/2 and the center is -1, 2.5, in order to get the equation of the circle, you sub into x minus h squared plus y minus k squared equals r squared, where h is the x value of your center, k is the y value of your center. So I subbed in here, I got x minus -1 squared plus y minus 2.5 squared equals √13/2 squared. Now luckily you don't have to multiply out the left hand side, you can just leave it as x plus 1 squared plus y minus 2.5 squared. But you have to square the right and leave it as 13 over 4. So I hope that video made sense. Again, as always, if there's anything you're unsure of there, then let me know in class or send me an email and I'll try and explain it a little bit differently.